Section 12.2, Frequency and Histograms. The objective of this section, to make and interpret frequency tables and histograms. Lesson vocabulary: frequency, frequency table, histogram, cumulative frequency table. An essential understanding: there are many ways to organize and visually display data. Sometimes it is helpful to organize numerical data into intervals. There are many ways to organize and visually display data. Sometimes it's helpful to organize data into intervals. The frequency of an interval is the number of data values in that interval. A frequency table groups a set of data values into intervals and shows the frequency for each interval. The frequency table below shows the same data from the solvent. So notice we have a table of values. The left-hand column represents the height in feet of trees, and not specific heights, but intervals, so ranges of heights in feet. Reading here what the book states, intervals in a frequency table do not overlap. That's important. Do not have any gaps, so we don't skip spaces, and are usually of equal size. Very good. If we begin using intervals that are not of equal size, we can be providing misleading data. To the right of that, notice the right-hand column represents frequency, or the number of trees in each interval. Reading what the book says, we see the frequency of each interval is the number of trees with heights in that interval. At the bottom, notice the entire table matching the data from our clipboard from the earlier problem. And example problem 1, making a frequency table. The numbers of home runs by the batters in a local home run derby are listed below. What is the frequency table that represents the data? The data are given here in this set beginning with 7, 17, 14, and continuing on through in no particular order and ending with 12, 7, 15. Note the minimum. The minimum data value is 2 and the maximum is 17. So we're going to need to make sure that our frequency table represents a range of 2 to 17, or a range of 15 units, but with a minimum of 2 and a maximum of 17. Now, we also need to figure out how wide each of our intervals will be, how many values each of those intervals will encompass. The book has chosen intervals of 4, and notice that works out nicely. In the first column of the table, we list the intervals. So that will be the column to the left. The intervals of home runs represent 2 through 5. Notice that's 4 different values. If a person has 2 home runs, 3 home runs, 4 home runs, or 5 home runs, they'll be included in that row. Followed by 6 through 9, 10 through 13, and 14 through 17, respectively. And then frequency. In order to tally up or count the number of home runs by batters in the 2 through 5 range, it works much as you might expect. 2 through 5, there's 1, there's 2, there's 3, there's 4, 2 through 5. Looks like that's it. 1, 2, 3, 4. Perfect. And finding the frequency for the rest of the intervals works much the same. And a got it question. For the data in problem 1, what is a frequency table that uses intervals of 5? A histogram is a graph that can display data from a frequency table. A histogram is a special type of bar graph. A histogram has 1 bar for each interval. The height of each bar shows the frequency of data in the interval it represents. There are no gaps between bars, and the bars are usually of equal width. So the steps involved in making a histogram. Example problem 2. The data are the numbers of hours per week a group of students spent watching television. What is a histogram that represents the data? Consider what we know, what we need, and make a plan. We know a set of data values. We need a histogram of the data values, and our plan is to make a frequency table to help us construct the histogram. Note, a lot of the information in a histogram can be derived from a frequency table. Note the frequency table at the bottom. Hours being the left-hand column, frequency, the right-hand column. Then use the intervals from the frequency table for the histogram. Draw a bar for each interval. Make the height of each bar equal to the frequency of its interval. The bars should touch, but should not overlap. Then label each axis. Pay close attention to the details involved in our histogram. We have the axes clearly labeled, showing our intervals, frequency, also clearly labeled, well enough that we can derive the height of each bar. We have bars of equal widths that touch but do not overlap. And finally, we have our axes units, hours, and frequency labeled as well. And finally, a title for our histogram, Watching Television. And another chance to show that you have got it. The finishing times in seconds for a race are shown below. What is a histogram that represents the data?